We did a little bit of this already. We walked through, and in our ways of proving stuff, we have side, 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 angle, side, angle, side, angle, 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 side, and then we kind of briefly touched on what's called hypotenuse leg. We haven't had to do any real specific proofs with that yet, but today what we're going to do is kind of just focus on that. Why does it work? It's a super easy one to show why it does work and go from there. Yes, ma'am? Too late. No, that's why I said you owed me two things. Man, hold the hair back over your ears. It'll help the filtering. So when we talk about this thing called hypotenuse leg, what kind of triangles are the only triangles that have hypotenuse? Right. So if we're talking about right triangles, the reason that this works is because it only works for right triangles. In a right triangle, where is the hypotenuse always located? Opposite side. Perfect. Very good. The hypotenuse will always be located the opposite side of the right angle. And that's one thing that's always for certain in these. Okay? The hypotenuse is always opposite the right angle. It will always be the longest side length. The other two side lengths of the right triangles are always just called legs. Okay? It doesn't matter which one's which, they're just legs. Now, the reason that hypotenuse leg works is because of this crazy little thing that you guys already know about right triangles. What's the crazy formula that you know about right triangles? Pythagorean theorem, right. What is Pythagorean theorem? Okay, you know that a squared plus b squared is c squared. That's what the book says, yes. Which one of those letters represents the hypotenuse? C. Hypotenuse will always be represented by C. This will always be the value of C. The other ones are interchangeable for being legs, A and B. And what happens then is that if you get, why hello? Why hello? So, what happens here, it's super easy to show you guys why hypotenuse leg works, because Pythagorean theorem. So if I say I have a hypotenuse that is 10, and then a leg that's 8, that means that these two guys are the same, and these are the same. Are we okay with that? Okay. Now, what we can do here to show the reason why hypotenuse leg works is because hypotenuse leg is just a shortcut from side, 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 or side, angle, side. Here's why. If I know that the Pythagorean theorem has to hold true, and the Pythagorean theorem will only work if it's a right angle, or right triangle. Pythagorean theorem does not work with any other type of triangle. Okay? What's 8 squared? What's 10 squared? 100. So what you can do is this. A squared plus 64 is 100. If I move the 64 over, what do I get? 36. Good. And what's the square root of 36? 6. So what happens here is that if you know two legs of a right triangle, you can always find the third. And since those two legs, or sorry, the two side lengths are already equal to each other, that means that the third side length also has to be equal, because if it's not, the Pythagorean theorem won't work. So what hypotenuse leg is, it's a shortcut from side, angle, side, by not having to do Pythagorean theorem. Or it's a shortcut from having side, side, side by not having to show it that right there. That's why hypotenuse leg works. That's why it's a thing. Yeah, Joe?
No.
That's why that does that. Now, this is a whole bunch of stuff that we don't really look at during this chapter, but we will go back to it later on when we get into right triangle stuff in the second semester. There are other ways you can use synthetic and theorem. We can use it to show if you have an acute triangle, an obtuse triangle, right triangle, a bunch of stuff. Okay. But for our intents purposes, the reason why hypotenuse leg works is because it's a shortcut from side, side, side. So, how does it work in a proof? Let's try it.
Are you drawing that?
Might not be a bad idea. Remember, it's always a good idea to draw the pictures. That way you can mark them as you're going. And remember, when we're doing proofs and stuff, make sure you got your progression sheet out with you. That way you can kind of keep tab, make sure you remember where everything is located.
Good.
So whenever you're dealing with proofs, where do you always start?
The given.
In this case, you are given that you have right angles. Now, on our progression sheet, we know that if we're ever given right angles, just to say that the right angles are then therefore what? All right, good. So we start with that. On our sheets, we have something on there that says if given right angles, just to state that they are congruent to each other. If not on a square of its own, that's part of the square for when you're dealing with perpendicular, if I'm not mistaken. So we just go ahead and say they're congruent to each other. All right angles congruent. Then we just make sure we have them marked up. Remember, the trick was whenever, after you get done writing something that is congruent, you're usually done with whatever you were just working with. Then you go on to the next statement. So our next statement is SP QR. It might be marked, you still got to write it down. So one of the things you guys want to make sure you bounce back and forth and looking at then is when you're at your diagram, in this case you see that you've got a set of angles, they happen to be right angles, and then you also have a set of sides, which happens to be a hypotenuse. So you kind of have the starting for a hypotenuse leg, but you don't have a leg portion. You don't have like another angle or anything yet. So what do you have? What do you have? Yeah, reflexive, yeah. It's just reflexive, guys.
Oh, crap.
Sometimes it's the most obvious thing, it's sitting right in front of you. Remember, it's called reflexive, it's not called shared side. And then when we mark up our diagram, Now you have hypotenuse leg.
Do we write it down?
Yes, sir. Yep. Just like we don't write out side the words or side angles. We don't write out the words. We just use the lettering. We do the same thing. So it's PRS, RP. And we just write HL. Because that's what that stands for. Okay. And then after you have congruent triangles, then remember all the corresponding parts are congruent. You can take that extra step with the CPC thing if you had to, and so on and so on and so on. Okay. That's so awful. Triangle. When we did this one earlier, we realized that as you're going through it, you actually get every single bit of information from the given in this case. There's nothing that you really have to make up on your own. So BE bisects segment AD. That means that you have segments off of AD now that are congruent to each other. Those two. And that's the definition of a segment bisector. And then you just go on to the next bunch. Perpendicular. What happens when you're perpendicular? What's created? Right angle's good. Do I have to use 3 letters for the right angle when AB is perpendicular to BC? Or can I just say angle P? Yeah, this is the example. You can use just 1 letter because there's only 1 vertex. Then I go on to the next one. I can't say that it's congruent to anything because I don't have another right angle yet. Since you're given 2 separate pieces that are perpendicular, you've got to say that those angles are formed before you can say that they're equal to each other. Yeah, exactly. And now you have angle E. And now you can say that they're equal or congruent to each other. So right there, we got 1, 2, 3, 4, 5, 6, 7 steps that was all kind of given to you. And you're not even done with your givens yet. I know, right? So the next one would be that last bit of given. I forgot what these segments were. But you see how even with one that looks like it's going to be awful, you're going to have so much information that all you really have to be able to keep straight is, can you mark the diagrams correctly to figure out which one of these 5 shows up? So let's see, what was it? A, B, D, E. And now we go back up and look at it. We have 2 sides in an angle, but it's not side angle side. And there's no ass in math, which makes this hypotenuse leg. Do you see it? Just a little fair warning, every time you've got a right triangle doesn't necessarily mean it's always going to be a hypotenuse leg. Just because you have a right triangle doesn't mean it's going to be a hypotenuse leg. You'll still see side angle side, you'll still see angle side angle, you'll still see angle side with those as well. Even in this example, bless you. Even in this example, you could have done something differently. What do you have around point C? You got vertical angles. So had you saw that instead of done the other stuff, you could have done side, angle, side. There's a couple of different things you could have done with that. But it just so happened that a hypotenuse leg came up a little bit quicker. That's why doing proofs are so weird, because there's so many different ways you can go about doing something. And as long as your sequence is right, you're not wrong. Yeah. Yeah, this was a nice one. In fact, that the only thing you had to figure out really on your own was how do you finish it. Excuse me.
What's the temperature outside?
40.
How late did you stay up last night?
Who, me?
Yes.
Not very.
I'm so tired. Me? I am very
It happens. Life happens.
Yeah.
Life happens and gets you going. All right.